Chapter 11, Lesson 2 is about arcs and chords. Then make sure to write this information down. A minor arc is an arc whose points are on or in the interior of the central angle. In this picture, the central angle is x, angle x. So my minor arc here would be the arc in between that angle. So the measure of AC is the same thing as measure of angle ABC, which is x degrees. The major arc of a circle is an arc whose points are on or in the exterior of the central angle. So my central angle here is still x degrees, but my major arc is the larger arc around the circle. So my major arc here is the measure of arc. This line right here means arc, ADC. When I'm talking about the major arc, you have to also include a point in between AC. Will be equal to 360 minus the measure of ABC, which is the same thing as 360 minus x degrees. In a semicircle, if the endpoints of an arc lie on the diameter of the arc. So here EG is the diameter of the circle. So measure of EFG, this is a semicircle. Semicircles arcs are always going to be equal to 180 degrees. So if I have this picture here, this should have an arc above it. This should be angle, arc, angle. So first I'm looking for measure of BC. So if I look at BC, I'm looking for this arc right here. This arc measurement will be the same thing as this degree measurement. Arcs are measured in degrees. So in a circle, there's 360 degrees in a circle. And arc BC is 13% of that circle. So if I write 13% as a decimal, it's 0.13. So 360 times 0.13 of 13% would be 46.8 degrees. And again, arcs are labeled in degrees. If I'm looking for measure of FMC, if I start at F, I go to M and connect with C. I'm looking for this angle measurement right here. So I have to add 9% plus 10% plus 11%, which would be 30%. And again, full circle is 360 degrees times by 0.3. You should always multiply by your decimal, which would be 108 degrees. If I'm looking for arc AHB, if I start at A, go towards H, and follow through to B, I could add up all of these percentages, but I notice that the only thing that AHB does not go around is 25%. So that means the percentage of AHB would be 75%. So I will do 360 times 0.75, which is equal to 270 degrees. And EMD. If I start at E, go to my M, D, that's 10%. So if I do 360 times 0.1 would be 36 degrees. This next part on your notes I do not have, but if you ever are looking for the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So in that picture, if I'm looking for arc ABC and I know AB and BC, I can add those two arcs together. Here I want to find all the missing angle measurements. The first thing I notice is that these two lines intersect. That means these are vertical angles. So if this is 25 degrees, this is also 25 degrees. The other thing I notice is that this is a straight line. So if I know 40 degrees and 25 degrees, if I add those two up, I get 65 degrees. So if I do 180 minus 65 degrees, it's equal to 115. Same goes for angle JPN. Since this is a straight line, this is going to create a semicircle, which will be 180. So if I do 180 minus 25 degrees, I get 155 degrees. Next part of your notes. This is the theorem, so make sure to write down this part in your theorem. Congruent central angles have congruent chords. So in this picture, it's stating that angle EAD, which is your central angle, and angle CAB is a central angle, are congruent. If those two angles are congruent, then your conclusion would be that DE is congruent to BC. So this is your theorem, and this is your conclusion. My second theorem is if I have congruent chords, then I have congruent arcs. So theorem is congruent chords have congruent arcs. In this picture, if DE, length DE is congruent to length CB, those line segments, then my conclusion is that arc DE is congruent to arc BC. So my two arcs will also be congruent. And my last one would be the theorem, congruent arcs have congruent central angles. So if I know that these two arcs are congruent, then these two angles are also congruent. Central angles always mean the angle by the center of the circle. If you're confused by that, it's always talking, central angles always mean the angle of the center of the circle. So I have this picture, and it says PT bisects angle RPS. First thing I have to think of is, what does bisect mean? That means that splits the two angles into congruent parts. So if I'm looking at RPS and PT bisects it, that means angle RPT will be congruent to TPS. So I'm looking for RT, this length. So I know that RT is 6x and SC is 20 minus 4x. Since those two central angles are congruent, so will be the chords of those angles. So if I'm solving for x here first, because I have to know what x is before I can find RT, subtract 4x from both sides, and then I'm going to divide by 10. So x is equal to 2. And RT is equal to 6 times x, so 6 times 2 will be equal to 12 units. You should try the next example by yourself and compare it to my answer. So it says these two circles are congruent, and CD is congruent to EF. So the two chords are congruent. That means the two arcs will also be congruent. And it gives us the arc measurement. So it says arc CD will be congruent to arc EF. And I'm looking for arc CD. First thing I have to do is find y. So 25y will be equal to 30y minus 20. I'm going to subtract 30y from both sides because I want to get all my y's on one side of the equation. And that says negative 5 times y, so the opposite of multiplying would be dividing. And a negative divided by negative becomes positive, so y is equal to 4. Now when I'm finding CD, I have 25 times 4, which is 100. And arcs and central angles is always labeled with degrees. Your homework is on page 760, 1 through 16, 19 through 30.